right, well, I think we might do is go ahead and get started. I'm not sure if we only have half an hour now. But I imagine that there's still some folks that are going to be joining in. So I'll kind of do a little bit of a slow roll. My hope is definitely to, yeah, it looks like there's still quite a few people joining in. But my hope is to definitely go through some content. I have, I'd say like 15 slides. And then I'm hoping to for sure have time at the end for questions. Love to connect with a group. Hoping to have this be a bit more interactive than just content sharing. But I wonder if there's anyone from Volta, if you could let me know when I should start, that'd be great. I think, or if they already announced everyone, all the rooms, and then got everyone in. If somebody could let me know, that'd be awesome. Then I'll just move forward. Okay, I'm gonna get started. It looks like that people are still going to be joining. Oh, great. So I see Lisa said that I'm good to go. Hey, perfect. Thank you, Lisa. Really quick, I'm going to try to, hopefully you can see my screen here. I put together some slides to really give you a sense on what, where I am coming from in this talk. Really, we're focusing on the current market drivers for onshoring the battery components, specifically focused on cathode active material. So I'll go a little bit into why cathode. And really why innovative advanced manufacturing techniques are necessary. One of the things that we heard in the last panel, which was very lively, there was a lot of content focused, or I guess key insights that came out of that. But one big area was that that I heard, which was, to have these supply chains really unlock, you need to be making the materials lower in cost than in China cost structure today, which means you have to have innovative approaches from not only kind of mining, refining to also making the key components. So I'll go through really why cathode material is a key element there, and then a little bit more of what we're doing, and then hoping to add up for discussion. Of course, if you can share your video, that's wonderful. Love to have a bit more of a open room. That'd be great, and we can definitely save time for questions at the end. Lisa, if you could share, I'm not sure if we only have half an hour since the timing went short, so let me know if there's anything else I should manage around for timing.
I didn't hear that part, but I think go ahead. Yeah.
Okay, go ahead. And then do we have does everything shut down at 10? So we have like about 25 minutes, half an hour? Most?
I'm not sure on that aspect.
But great. Let me know if I'm going to work under that assumption. But great. So who am I? My name is Virginia Klausmeier. I'm the founder and CEO of Sylvatex. So I'll get to Sylvatex at the end of the discussion. My background's in chemistry, engineering, and economics, business, really. I'd say my passion has been over the last 15 to 20 years to really make industrial manufacturing be in the most efficient way possible. So environmentally friendly, low cost, et cetera, to lower the cost of energy, improve the lives of everyone, and be able to make these industrial processes not toxic so that they can be utilized all over. I'm sure there's many of us that are really focused on impact. That's why I'm here today. And at Sylvatex, we're really focused on solving two of the biggest problems that are driving the energy transition. One is that costs are still way too high for batteries. And two, geopolitical risks and mandates are driving the need for regionalized supply chains in the West. So really, and this can be my last pitch about Sylvatex until the end, but what we're doing is transforming the approach to simple, flexible manufacturing. And our mission is to really revolutionize the energy sector by targeting the highest cost component of an EV and energy storage system, which is cathode active material. So just to dive in here, there's a lot of, there's no question, there's a lot of moving elements that are driving these markets today. National security concerns, these are consistent wherever you are in the region. If it's in the US, you hear it with the same in Australia, India, Europe, etc. Accessing local material supply. So that's definitely a key concern wherever you are as well. It's a key theme. Being able to have access to supply chains and also manufacturing for domestic job opportunities. So this is a consistent message too. And then you have other elements to really have reduced and or better cost structures and reduced tariff risks. So these are kind of key themes that are consistent in the market that sometimes are in conflict with each other, but nonetheless, very dynamic. So why cathode material? So we focused on cathode material because if you look over here on the left-hand side, cathode active material, just this black powder. Okay, let's see if I can get this out of view. There we go. Okay, it's just black powder. This accounts for sometimes over 50% of the cost of the battery pack. So it's the largest cost component for sure of the battery compared to other materials, especially if you're looking at solid state batteries, that sort of price distribution goes up there. And these markets are growing substantially. So, they're growing into $100 billion markets quite readily. And, I think the way I see the world is that we're in the largest industrial transformation, energy transformation of our lifetime. So, this is a huge opportunity to capitalize off of. There's been a lot of, and I wish I could see everyone that's here. I'm very curious how much you know about cathode material, so I'm not going to spend too much time to dive into details, but happy to answer specific questions. But there has been, I'd say, over the last few decades, a lot of movement of, different cathode active materials. It was more of a specialties market. Now these markets have grown substantially from energy storage and electrification and really consolidated on probably two chemistries: LFP, so lithium iron phosphate, and NMC, nickel manganese cobalt. And if you look at this kind of forward-looking curve, it's kind of funny. In 2018, the projections were very different. So I think the projections were that NMC were going to be market dominant. There's been a lot of shifting where LFP, and you heard it in the last panel, is definitely becoming more of a market player. And then you also have, not only electrification, but also energy storage dominating that growth as well. So what that means is that even though there's been a sort of breakdown different chemistries, there's two major dominant chemistries. The processes to make these materials has been relatively, for each of them, really non-inflexible. So I'll kind of cover why that point matters. But the sheer piece is that there's a difference in all chemistries, which makes a difference on where the critical minerals or the materials that are being used to make these chemistries comes from, right? So when you're thinking about the world at large, a lot of the opportunity and a lot of the growth is in the Western world. So all the demand is kind of coming from North American market, European market, and the Japan and Korean market. What you're seeing, though, is that the supply to support that demand, it's definitely maintained concentrated within China. This is a natural, I'd say, natural progression that you see in industrial manufacturing all the time, is that first you start off with smaller scale, it's concentrated in one area. I think, Ken, you mentioned that in the last talk that every part of the world kind of chooses this different piece of these big supply chains to become market dominant in. But I think the big thing that batteries, I don't see a lot of people talking about, is this transition of actually going into energy. So going kind of from consumer goods to transportation to energy, is the volumes are so much larger. So you're moving towards commoditization and scale, which you have to have supply closer to demand, just generally. Sort of big high level, when you're looking at cathode material, the production outside of China generally is about 2x cost structure, because of cost of labor, cost of utility, a lot of the costs, if you just kind of take the process that's done in China and move it over. And then you have, this is a little bit more of a nuanced piece, but you have rate limiting steps like water utilization and waste that are the rate limiting steps usually in permitting. So that's caused a lot of complications of the scaling up of cathode material, not only in North America, but there's good bad examples about kind of scale within Europe as well. But when you're looking at all of these markets, there's clearly dominance. China's done an amazing job on building out the supply chain. It's been a coordinated long-term plan. Definitely dominate the lithium-ion battery production, EV cell production, and EV production today. With Europe is definitely expanding, and then you're seeing North America and other parts of the world as well. This chart may be a little old, but still, I think that there's definitely a cell production that has been brought to, and I'm going to say for some of my examples, a little bit more focus on the US just to have a targeted piece of conversation, because we only have about 20 minutes to go through this. But there is battery supply coming on board. There is a growth in the EV market, in the energy storage market. The batteries for energy storage cells, I don't think have really even started to expand in the North American market, but that's because no one really had to. The cost of cells and producing and getting access to the cells in China really hasn't been massively disrupted until a lot of the tariff elements. So it's, the EV markets were forced already to think about this. So I think that's where you saw a lot of the focus in the supply chain growth. However, you're starting to see that with energy storage now pretty robustly. What we see, and I think this is general within the market, is even though there's definitely a lot of discussion about kind of the slump in growth in electric vehicle sales and things like that, I mean, you're still seeing gigafactory production. I think the component which is really interesting, separate from electric vehicles, when you're thinking just of batteries, is the amount of energy storage that's going to need to come online to support data centers is quite significant. And that's going to definitely play a factor in the number of batteries that are going to be built. So again, I'd say these markets are incredibly dynamic, and my goal isn't to kind of go deep into all of the battery markets, but mostly saying, hey, look, they're growing. They're growing predominantly in the West, and you need to have supply closer to where they're growing. When you look more holistically at the different parts of the supply chain, so I think first it started with EV, looking at the EV supply and trying to have the car companies pull the battery manufacturing, have that battery manufacturing more localized in its different regions. So you're already starting to see that Europe and in North America. But then when you go to look at the cell components, specifically cathode material, and actually if you do this breakdown and look at the CAM production for LFP, I think it's something like 95% comes from China. So it's very predominant in and concentrated within China. And then, China's also done a wonderful job on securing a lot of the material processing. But when you look at mining, where the materials come from, that's distributed. So the thing that's, that is really exciting about this market is it's a global, there's a lot of global moving pieces that make it very dynamic, that you have to be, and there's a lot of, I'd say, different, within these different regions, everyone wants to create economic value, right? So they don't want to be just extractive. And I think that different regions are definitely trying to figure out where do they play their part in the system. Let me see. I'm gonna bump to this one first, and then switch to the next one. But I really like this global map that looked at some of the lithium supply. This is a little bit outdated, but I think the general, there's definitely more supply of lithium that's been, that's found, et cetera. This is more looking at where materials have been starting to be extracted in the mining. There's a majority of the mining is in countries outside of Europe and North America. I mean, that's pretty obvious, even though there is some active materials that are definitely starting to be sourced here. And then you have recycling supply chains that may grow over time, or will grow over time for sure. But generally, when you look at the all the components that there is to make a battery, it's very distributed. So that's where a lot of the regulations and the cost structure around tariffs plays into effect. Where do we have partnerships? What are the different chemistries that and critical minerals that our partnerships have access to? And how are we going to own or support different parts of the supply chain? So sounds easy, but it's I'd say a complex problem. And when you're looking at specifically cathode material, this was a great summary that McKinsey put together. I think it was end of last year, but there's quite a bit of white space. There's some talk that there's oversupply in the cell production that may be coming online by 2030, but not really in the active materials and not in the critical minerals. So I think that it's really well known that the sort of refining and the mining has been, in this region has relatively not been high, and the CAM capacity and active material capacity has also been low. So we still see a pretty significant gap there of these very, very large markets where supplying this material that is the largest cost component of the battery is not really coming online. One of the big pieces is that, is connecting these two dots is how do you actually build a facility in these regions in a cost-effective way, but also be able to do it that meets environmental and siting regulations, which, does roll up into generally cost. The piece that what we've seen that's quite interesting is this kind of last bullet is that actually building capacity and scale, the rate limiting step has been the water utilization and the waste component. So that kind of goes back to that you have to do things differently than how they've been done in China, because in China, that cost component, when you're looking at a full techno-economic assessment, water and environmental effects really does not come into play. This was mentioned in the last panel too, but there's this very strong pull, or maybe it's just noise, but it seems like it's true around critical minerals and a focus on trying to do build these supply chains on extracting critical minerals and going through processing of the derivative products more, domestically for national security. And, I think that the piece that is the bottom line is that with, you have to maintain that supply of the sort of the end market cells. You have to be able to, if you're going to be doing the critical minerals extraction and processing, you have to do that within the same region. There's no reason that we would extract a bunch of materials and then send them off to do processing. And we need to turn them into the high value component cathode material here as well. So to make all those pieces be done in a way that's cost effective, you need to have innovation to connect not only critical minerals with the cell production and supply, but more so be able to unlock and allow for the economic resilience and the national security that, I'd say is globally needed in each region. So this is a little bit of a pitch if you're interested, but the area I've been quite passionate about is really thinking about these systems. So how do we more efficiently look at the world of this big problem around creating these active materials for batteries to lower the cost of batteries, make them have a lower carbon footprint, and also make them more regional. The hypothesis to, really future-proof the supply chain is that you have to have regional supply chains. And I'm not the only one that thinks this. You talk to a lot of the major OEMs and cell OEMs, they're moving towards regional supply chains because the risks and the instability of just the of just the supply chains from if it's war, tariffs, or other issues associated, with movement from like COVID, you need to have more focused regional supply chains to have that market stability for these materials that are targeting in these energy sectors. So this is a link if you want to read the more detailed article, but we put together a summary and worked with the World Economic Forum on really highlighting the need for more regional supply to future-proof the production of battery material components. Okay, so this is gonna be rapid fire because I definitely want to get some questions in there before we get cut off. All of these components lead to the price of batteries need to go down further. So you could argue that it's definitely much lower than $80 per kilowatt hour is where the goal is. But nonetheless, to drive the cost down, you really need to, cell manufacturers and OEMs, their priority is lower cost and localized production. To kind of give you a small little data point, if Sylvatex in our process was to use our process to make NMC for Tesla vehicles last year, we would have saved them 1.5 billion in annual savings just to be, just in the actual production process and their direct costs. So it's a pretty significant savings just from having innovative manufacturing. Okay, little high level overview on traditional process. So I'm going to just stick with NMC for this, given that it's more complex of a process that is more prepared with problems to expand outside of China, just on the environmental side. But when you look at this process of making NMC, the traditional process has remained relatively unchanged for 20 years. It's a multi-step complex process. It has large amounts of water that's used, large amounts of waste that comes out of it, and the sodium sulfate. It's very significant and a big problem. These are complex facilities, and one of the things, these are billion-dollar assets, and they have very little to no flexibility on their end product or input product. So you have to have highly pure metal sulfate inputs that go through a co-precipitation process. And then you can make NMC 622, and not really have the same plant that can be reconfigured that well to make NMC 811. So they're really inflexible as far as industrial assets for this kind of ever-changing market. What we designed is a process that we call future-proofing manufacturing. It's a patented process that is a simple single-step dry method. So we use no water, and we allow for a broader range of input and output flexibility. So the innovation really centers around process simplification, a unique synthesis pathway for making mainline CAM materials. So just to be very clear, I believe in the existing market for cathode material and all the mainline cathode materials. We're not trying to make novel materials. That's not our goal. But we have been able to show, and our goal is to make a system and a process that is much more simplified, lower in cost in CapEx, but is flexible across all the different chemistries. So if you want to make LFP and switch that to LMFP, great. You can use the same process and do it better, faster, cheaper. We've been able to, the real element that is breakthrough on our side is that we leverage a lot wider range of alternative raw materials. So for, of course, it's dependent on the different end chemistries you're looking for, but in general, we use oxides and hydroxides, which are less processed. So we, by nature, don't have any of the sodium sulfate waste. And then we add an organic additive that plays a critical role in bringing these materials together in a dry fashion into the calcining process. And one thing that is pretty interesting is that we also, innovation can be hard. We try not to innovate on new materials and/or equipment. So we're using all off-the-shelf equipment, which is really important for large scale distribution and really, let's say, high fast adoption. And why does this all matter? So just to connect the thought process on all of the different threads to have domestic supply chains or to have supply chains outside of China, you need to have a cost driver. It all comes down to unit economics. So you have other drivers like national security that definitely roll up to some type of cost element. You have tariff challenges, but when you're looking at true innovative solutions to be growing in different regions, you need to have a natural margin. So what we've done in our process is that if we look at NMC compared to materials sourced in China and produced in China, which is usually as cheap, as low cost as you can get. Mostly the bill of materials is the highest cost component, and then you have the OpEx. We drive OpEx substantially down, so reduce the number of steps substantially. We also allow for less refined materials to be used. So we can use MHP, for example. So we lower the cost of bill of materials and we increase that margin potential. So the overall goal is to have cheaper battery components to create cheaper batteries and pass that savings, have a higher margin that we can pass some of that off to the customer as well. So not only are they buying lower cost cathode material, but also they're saving all of the costs that they would naturally have to pay on the tariffs. So that is a huge savings. I know in this model, I outlined about 80% of the tariff costs, but I think we just heard that it's like 140. So these are really big numbers when you're looking at building the batteries and adding that cost onto your projects. Let's see here. I think, so I have only one more slide and then I just want to close, but the way that, I think some of this was mentioned, but it's really important to we position ourselves into a new category of efficiently scaling up to large scale and commercialization. So we leverage this by having a unique business proposition. So one, having us be waterless, zero waste. We use off-the-shelf equipment. It's much lower CapEx. The investment upfront is much lower and the risks are much, much lower to actually scale in the West. And then on top of it, the process innovation unlocks the ability to have and leverage lower cost unit economics because we can also leverage more domestic available feedstocks to be compliant or have better cost effectiveness there. And also, we have product flexibility. So we're really driven by the customer on meeting their specifications and have the ability to have more flexibility, which is really at the heart of our innovation, is adding more flexibility into these materials as they grow in market dominance. Great, this is my wrap up, and hopefully we can think of your questions. But I think that there is definitely a lot of movement that is happening now in the market. There's massive economic tailwinds and headwinds for sure. The headwinds are mostly on getting access to capital. Cathode material is definitely a shortfall in the supply chain, and cost is the dominant component there. And what you're seeing now is that there's a lot of focus on domestic supply chain. So I think we really saw that part of the future and have innovated well to support this industry thrive. Awesome. Okay, great. I see some questions. I think, why don't we just go in order here? I don't know how to actually say your name. Is it Radhaif?
Yeah, Raghav.
Radhaif. Oh,
Hi.
perfect.
Hi, Virginia. This is Raghav from New Delhi. I remember speaking about a year ago to your colleague who's from, I think, A123 Systems and I think MIT from Boston. He has short hair. This was about recycling iron waste into cathode material.
Awesome.
And so I just wanted to continue that conversation and talk about bringing your technology to India.
Perfect. Well, we would love to. And also, I know I didn't cover it in this fast pitch, but for those of you on the phone, we do use iron oxides as our feedstock for the LFP, which is a novel approach to have a broader access of inputs than iron phosphate to leverage lower cost components. So it would be great to talk offline. I realize maybe it's not on here, but I'll put in my chat the my email. And then also Brooks, I'm not sure, my colleague is online here too. He could also add his email as well, and we'll make sure to have a follow-up discussion, but that would be great. Try like
Thank you so much.
India's expanding so fast, and in a much more coordinated way, than in the region for which we currently sit. So I'm very excited to support that region.
Wonderful. We'll welcome you here, ma'am.
Perfect. Awesome, Tom.
Yeah, thanks, Virginia. Very interesting talk. I was 15 years at Umicore, so the cathode business is something that's very close to my heart. So really nice to see some new developments here. Maybe two questions on the supply. You mentioned, yeah, you're not following the traditional routes of sulfates, but how are you going to convince the supply routes? Because some of these materials, like the manganese oxides and or hydroxide, might not be that widely available. So that's maybe like on the supply quantities. And then you also said something interesting on using MHP as an input. Like, how do you get rid of the impurities that are in that feed along the process to get to your very high purity cathode? I'm not sure if you could elaborate a bit on that.
Yeah. So we've seen, we're seeing the oxide markets really grow. I mean, quite honestly, we met with Umicore early in the days. I got to meet with the CEO in Davos a couple of years ago, which was wonderful. And I think the insights that came from that was a couple things. One is that the waste that comes off the current process, the sulfate waste, is a really big problem in scaling in the West. And I don't think that we've, in the sort of techno-economic models that we've gotten access to and designed with third-party experts, they don't really take that into account. So it's a really big gap. And with that, the other gap that was quite interesting when you look upstream is that most of the nickel had come from nickel sulfate inputs. But then when you look now in the future, where all the nickel's coming from over the next 5 years and then the next decades, it's coming from nickel oxide ore from Australia, Indonesia. So you have MHP as a growing input of midstream. Generally, MHP trends at about 25% lower than nickel sulfate. And that is very, I would say very available now on the broader markets. There's much more simplification on taking MHP and doing processing to get rid of any additional contaminants and manage it down. So that, I'd say those areas are becoming much more advanced, and the supply chains are definitely robust. So I'm not too worried about the supply chain. The part that's really interesting to me was that it seemed really silly to have, nickel, manganese, and cobalt all together, and then have to separate them all in a high purification, add a sulfate molecule, send them all over the world, and then make cathode material. That does not make it sustainable. So at least having components where you're in a process, our single step allows us to use either spent recycled materials more efficiently, or like MHP as a feedstock more efficiently, because it's a single step as opposed to having to have a multi-step PChem process. Hopefully that helped a little bit. But yeah, I'm definitely inspired of where the world is today and where it's going, and also having the real conversation of the rate limiting steps of why these industrial processes are hard to scale up. So I'd love to talk to you more offline on your experience, and I'm curious about what you're doing now, so I'm super curious on what you've done with that. Yeah.
Yep, glad to follow up.
Sweet. Perfect. Yeah. I think, my colleague Brooks just put his information there too, but please look forward to connecting more. Taylor, love to hear from you. I like, hopefully you guys see the same order I see. So I'm not, it's in order. I'm not just picking favorites randomly.
Gotcha. Yeah. No, appreciate the presentation. Very interesting. I'm actually with Echion Technologies, and we're more on the anode side of the material, but we are oftentimes paired with an NMC type of cathode. And we're scaling globally on with battery producers, and North America is a big focus for our market, as is Europe, in scaling like premium ultra fast charging, ultra long life batteries. And our anode material is a mixed niobium oxide. And so what I'm curious about is, there's definitely advantages in helping to bring the cost down on the cathode side. but also as you get into some of these premium anode materials, there's a similar problem. And so I'm curious if y'all have looked at, the other side of the equation to say, yes, this also scales into those processes as well, and what that might look like.
Great question. And I'm sure you're pretty sensitive to the fact that as a small company, you have to stay very focused. So one of the areas that we stayed, we are very focused on not designing novel chemistries, but because our process is so much more flexible, we have a broader range of of capabilities of making kind of more niche-y other materials. So we've been asked to do a lot of different things. We do have an active grant with RBE that is specifically looking at our LFP that's made domestically at a lower cost advantage and matching that with other anode or other battery innovations that allow for a much higher performance. So I think their overall program goal is to have a much higher performing, lower cost battery for a broader market. So yeah, we're definitely very active in that, but our resources are focused more on the process itself versus like the interactive chemistries and really looking to the partners. Because usually if you're doing something novel, you recognize the other novelty component, matching component that is going to aid in better value. That's a little outside of our scope in our current competency. Yeah.
Sure, sure. No, I think it's interesting because a lot of well, we've had a lot of interest from battery manufacturers is because we're able to slot into their existing production processes without really any capital changes. So I'd love to link up with your team and get a little bit better understanding of if there would be some synergies, just due to the fact that where you run in very similar processes and yeah, anyways, very, very interesting.
Yeah, would definitely love that. And one thing that you just sparked on the sort of the thought process. I know, Tom, with your kind of background from Umicore, leveraging existing assets and those supply chains for that equipment is so important. Like if you do not have that ability to kind of like leverage that. I mean, for us, we take a lot of steps out, so that just becomes less relevant. And then the equipment that is relevant is the milling and the calcining and the sort of post classification. But those like leveraging those vendor relationships and that equipment and supply chain is absolutely necessary to de-risk or scale up over the next 10 years for sure.
Yeah, absolutely. Well, I love what you guys are doing on the NMC side. Regardless, that's a huge.
Perfect. And we're doing it for LFP too. I just only focused, we're targeting LFP, making it cheaper, like in North America with oxide materials, cheaper than China, and NMC 811 single crystal, having that cost advantage as well.
Excellent.
Awesome. Thank you. Yasuko, is that how you say?
Yes. Thank you.
Oh, perfect.
Yeah. Thanks for the presentation. And I don't have a webcam, and sorry for that. Yeah, you mentioned production tax credit and incentives, and I'm wondering what the current stage of IRA and production tax credit, Section 45, and so on. I know that Trump administration announced pausing IRA expenses on the first day, but I haven't heard if that was formalized after that. So if you know the current status, that'll be helpful.
Yeah, I think they on the panel a little bit, there was a woman on the panel, I'm blanking on her name, but she seemed to know a lot about a lot of the moving pieces. When you're looking at the tax credits, what we tried to model was only looking at some of the additional 45X, which comes from production tax credit. From the latest I've heard, that does not look like that's under fire. The part that is potentially the EV tax credit of that makes it lower cost to purchase the EV and getting that tax credit for the consumer. That's I think only in the US, but that too has not yet been really fully in play. But I think that the industry generally expects it's going to probably go away. I've heard lots of things on different parts of analysis from that doesn't matter because the amount of cars that actually got that tax credit was so low that it actually isn't going to make that big of a difference in the supply. So I'm not an expert in that level of analyst detail, but there is a lot of information out there. My general sense is that the market specifically for batteries is probably going to only enhance at a more rapid rate, not only because EV is going to maintain in scale and need, but you see this big push of having domestic critical materials, and
Yep.
you have to be putting those into the battery supply chain. So you
Yep.
have to be then making the CAM that it goes into to leverage that. Otherwise there's no market and that makes no sense. So
Yep.
I would say that's a little bit above my pay grade, but I think that smart people are making sure that that's pretty obvious in those markets. But I would say specifically for our area, looking at the unit economics of the materials, that's where the tariffs really play in. So I just shared this slide again. And from talking to folks that are very skilled in the space, the production tax credit does not seem like that's going away, since a lot of the capacity is in like states that are red. So that's not expected to really go away as an incentive.
Yeah, that's my expectation as well. Yeah, looks like everyone's, talking about tariff and trade issues and forget about IRA. So let's see what happens in
Yeah,
next maybe 6 months time frame, I guess.
hopefully sooner than that. But yes.
Yeah. Yeah.
Hopefully sooner than that. Love any other questions. I'm so grateful that maybe you stayed longer. Happy to also field any questions directly offline. And for those of you that may be interested, happy to be able to send a link. They probably are going to send a link to this video, so you'll be able to see the presentation from there. But love if there's any other questions to cover them for the rest of the group. I see. Oh, perfect.
Yes. Hi. My name is Eugenia. I most recently was at Innophos, phosphate processor or producer in North America. One of the questions I have is the Sylvatex process. I was not familiar with it until your presentation. Is it in pilot scale? Like how prevalent, is this, can you share with us any,
no,
is
please.
this and how, and how, is it at scale or is it being piloted in pilot facilities, and is it US or Europe? What are the
that's
concrete
great.
examples?
Super good question. We have done everything. We're based in Alameda, California. Sorry, I just breezed over all that because I was trying not to make it too Sylvatex focused, but we are a small team, lean and mean. We're now moving into tonnage scale this year. We have worked with engineers to build the pathway on what is the smallest commercial facility we can build that allows for qualification with sort of high tier EV customers. So that's about 100-ton facility. So that's the next in view. We intend to be either, and right now we have 2 product types that we've been focusing on making, matching with high purity industry specifications. One is LFP, so making that low cost domestically with domestic feedstocks. That's the iron oxide and phosphate inputs. So that's where it's like pretty interesting. There's a lot of opportunity there for leveraging a broader range of inputs. And then with the NMC A11 single crystal. So those are kind of our 2 product offerings. We're probably going to be focusing on one product in the near term and have more of a staged expansion, but we are working with through qualification with at least 10 different customers right now on kind of the pre-A sample, A sample type stage.
So your business is a licensing business, a process?
No, we're
Like,
scaling, we're scaling up. Our intent is not to be licensing, although for our friends in India, we intend to work with
Okay.
partners in those types of regions, but, and find a really good commercial licensing partner, just because of the stage and age and how fast that region is growing. And we want to offer them a pathway to do the process that is, very low, like low cost, but also has none of the waste and water utilization energy. So, but yeah, no, right now we're moving quite aggressively to scale. Over the next 2 years, we'll have our commercial demonstration in sight, and then we'll be able to run a parallel program for commercial scale set assets and do project financing and build and scale that.
Thank you for the presentation and also for the detailed answer.
Great. Thank you. Perfect. Well, I think we're sufficient. Is there any other, I'm not sure if Lisa's on the line, but I know that we are about 15 minutes over, so I'm sensitive to everyone's schedules, and a number of folks are in different parts of the world, so it's very late. I am happy to answer any other questions offline, but my sense is that it's